I'm going to talk to you today about what we're doing in AMY around smart infrastructure and innovative asset monitoring. First of all, I'm going to talk about why do we need it, and then how we do it in AMY, and then I'll give you an example of what we're doing on the Smart Bridges project. So why do we need it? Well, smart assets are becoming quite common in sort of discussions around infrastructure. But we don't just need them because of buzzwords like it's the fourth industrial revolution, Internet of Things, big data, artificial intelligence, etc. They're all exciting things, but we shouldn't be doing them just because it's the latest trend, and we shouldn't be doing them just because it's good to have data. Yes, it is good to have data, but why do we need data? We need data to make better decisions. So that's what we're really focused on. It's turning that data into information to be able to have better insight and then make better decisions, which then has a positive impact on things like performance, cost, and risk. And those three things all combine together to have a positive impact on things like productivity, the theme for the conference today. So how do we get that better decision then? How do we make that link between the data and better decisions? Well, we need to make sure that we're getting the right information at the right time and in the right format. And we've got lots of tools available to us today. One of the key things is sensor technologies and cloud computing. So we're maximizing this in AMY Strategic Consulting to support the rest of AMY with the infrastructure that they're managing. And we also help other clients as well. It's pulling all this together that's the interesting and exciting thing, I think. So how do we do it in AMY? Well, we're taking a collaborative approach because AMY is a big company. We've got lots of different teams that manage lots of different bits of critical national infrastructure. What we have to make sure is that the requirement for this smart infrastructure is driven from the engineers that are managing the assets, the project managers, the project teams, and also, crucially, the client stakeholders as well. So we make sure that whatever we're doing, it's driven from the requirement of the people that are actually hands-on managing these assets day in, day out, and understand the decisions that they are making. We also have teams in AMY that are experts in sensing technology, remote monitoring technologies. So we link up with those, but not only just in AMY, we also have sort of a rich ecosystem of suppliers that we use for that, because we recognize we don't have all the answers and can't do everything. So we link up with external people as well to help us apply these sensing technologies to our assets. And then the team that I work in is the sort of data science team. So in my team, we've got people who've got, for example, PhDs in machine learning and predictive analytics. We do a lot with data. But it's pulling all these things together that really allows us to work together and sort of empower that decision making with data, turning assets into smart assets. We have developed in strategic consulting an in-house AMY platform called Mercury. Don't ask me why it's called Mercury, somebody came up with that name. And Mercury helps us enable those decisions by using the data. So it pulls all this together for us. I'm going to tell you a bit more about Mercury now. But the important thing is that we're able to provide an end-to-end solution, turning data into useful decision-making and positive impact, because we work together with those sort of three key elements there. So what is Mercury? Mercury is an IoT, so Internet of Things, remote real-time monitoring and analytics tool. We developed it a couple of years ago in AMY, and we're using it across a whole range of different assets, from civil infrastructure through to mechanical and electrical assets as well. Doing it for Transport Scotland, the Fourth Road Bridge example I'll show you, but also in things like lifts and escalators, network rail tunnels, waste treatment plants, so a whole range of different things. Because the key thing about Mercury is that it doesn't care what assets it's monitoring. It's completely sensor and asset agnostic. So it enables those asset managers, those engineers, to make better decisions by providing them the insight on the assets. So sort of going around this circle here, you can see that to begin with, what it's doing is taking in data from lots of different sources. So that could be IoT sensors, it could be PLC, it could be SCADA. It also overlays that with intervention logs such as your maintenance management system, and also things like email data. Basically, you can scrape data from any source and overlay that in one sort of holistic page to allow you to be able to make better decisions. We can also have structured and unstructured data, so that's quite a difficult thing when you're looking at data and smart assets. The type of data that you need, Mercury allows us to overlay different types of data. So once you've collated all that data, integrate it and visualize it in a nice, fairly easy to use platform, we can then provide analytics on the go. So by that I mean it's real-time live analytics with the real-time data. We have custom thresholds for alarms and alerts to ping out, go and look at this because this alert has just been raised. That can be in text message or email. We also provide automated reports, so they can be scheduled reports that will be generated automatically after, say, an extreme weather event, or on a time basis, depending on what the engineers need. And we also have machine learning algorithms in there. So this allows us to learn a lot from all this huge amount of data that we're collecting, start to build up trends, and then inform the decision making by saying, well, this is how the asset responded in the past to these conditions, this is how it's likely to respond in the future. That also helps us with things like anomaly detection, which is another big thing when you're doing data analytics. So Mercury on the Forth Road Bridge, getting this down to a real example. Amy have the contract on behalf of Transport Scotland to operate and manage the Forth Road Bridge crossings. Just to give a bit of context, so they're hugely important pieces of national infrastructure. They transport about 100,000 people a day, use them, and they contribute £1 million a day to the Scottish economy. So keeping them open and safe is very important, especially in terms of productivity. They are a large and complex group of assets. So Amy have to make sure that the 30,000 plus elements that comprise of the bridge are looked after, or you know exactly the condition they're in. Amy have to do all these functions, inspect, monitor, etc., down to enhance and renew. So being able to make those decisions about where do you invest money to enhance and renew the bridge to keep them open and safe is really important. And it's not just open and safe, it's resilient and also have a long service life. So how do we get the most out of these assets? And actually it's nice having the balance of the old and new with the Forth Road Bridge crossing and with the Queensferry crossing, so that you can see that actually we're making the most of having the old asset as well as bringing new asset into service. But what can go wrong here? So I don't know if any of you remember, I know I spoke to the Transport Scotland lady earlier who remembered the Forth Road Bridge being closed back in 2015. There was a problem with one of the truss end links where under extreme loading it had actually fractured because it wasn't articulating as it should have been. This was the point that sparked, we need to do something different. We need to manage these assets better, more intelligently. So at that point, we started applying sensors to the bridge to monitor the critical parts of the bridge to tell us how the bridge is responding in real time to weather conditions. So the solution we now have in place is that we're collecting data from a whole multiple load of data streams. We're looking at things like effects on the bridge. So we measure wind, speed and gust speed. We measure vehicle weight. We measure temperature. And then we're also measuring the response of the bridge to those effects. So things like force, moments, displacement at the bearings, stresses. And we might get in raw data such as strain data, and then Mercury will transform that into the stress and moment data. That helps us build an understanding of the bridge. So we're able to ingest and analyze these big data sets. We can start looking at correlations between different variables and evaluate different patterns and trends. That all helps build a much richer understanding of how the asset is actually performing and behaving. We monitor in real time and then we predict as well. So it's great for the inspectors to be able to know if there's any issues arising, which they can then feed into their inspection plans. But that's in a real-time sense, which is very useful. But also what's becoming more useful is being able to predict the response of the bridge in future. So our machine learning algorithms are able to say, looking at the weather forecast for, say, the next 72 hours, how do we pull that data in and put it through our machine learning algorithm to say how the bridge is likely to respond to those weather conditions, which gives them a heads up about sort of things they might have to do with the bridge, maybe close it to certain weighted vehicles, etc. So we're still learning about how useful the predictive algorithms are, and really, how much confidence we can take in putting those algorithms to use in terms of real decision making. But it's a learning journey, and we're definitely being able to maximize the use of this data. So what we're able to do, definitely from the real-time monitoring and from the real-time analytics we're doing, is being able to confirm the safety of the bridge, assure that something like what happened in 2015 will not happen again, and also respond in real time to the alerts and alarms, and be able to say, right, from our inspection regime, where should we be prioritizing inspections, where should we be prioritizing replacement and refurbishment activities, which all then feeds into how do you prioritize your investment and budget planning. So just for those that are interested, the truss end link was redesigned, so there's the new design there, and this is where we've placed sensors that are looking at stress, load, bearing wear, and movement. So I'll just show you as well where we not only did the truss end links, but we also did the side towers, which are at the very ends of the bridge, to look at displacement and strain at those as well. And we're actually sort of adding, as we realise what's useful, we can then add more sensors retrospectively. And certainly the Queen's Ferry Crossing has had so many sensors designed into it and embedded into the structure. Okay, I'm going to show you a quick video, which is quick. For some reason, it's sped up as it was embedded in the slides. But just to give you a feel of what the engineers will actually see when they're using Mercury. So this is the landing page, and you can see a high-level view of the bridge, with sort of like red, amber, green status of what's going on with the various points we're monitoring. And then in this alert section here, that's it. In the alert section here, you've got where alerts were raised based on various different thresholds. So from the high-level view, you can quickly drill down into areas you might be interested in. So quickly drill down into where an alert was raised, look at the real-time data that's coming out of those elements, an interactive graph, you can drill down into that. Also raise where the point in time of that alert was raised. You can produce sensor heat maps, etc. Go into a summary page of the data you're particularly interested in, interactively change the timescale that you're looking over, depending on what it is you're interested in seeing. So for example, here we're saying, let's change the period of time we're looking over, and then we'll go down to the predictive analytics bit. So if you pause it there, just to explain what's going on here then. So here we've got the orange dot is what our machine learning algorithm has predicted. This is bearing displacement, has predicted the bearing displacement will be based on real weather data, so actual real-time weather data. And then the blue is overlaid on how the bearing actually did respond, so the real bearing displacement. So there's a fairly good correlation. We think it's about 70% accuracy at the moment. But the thing is, with the machine learning algorithm, it's learning every day. Every day it improves its accuracy. So if you carry on the video there. So again, all this is interactive. We can go and do some real-time analytics as well. So for example, this is correlation analysis. You can correlate any two variables from any two sensors that you want to have a look at what the trend looks like. Histogram analysis as well, time series analysis. Again, just literally any data that we've got in here, you can have a look at and start to learn and investigate trends. Also on the reporting side, here we've got predictive analytics reports. If you just pause it there again, please. Thank you. So here you can see that what we're doing here with the orange is actually predicting what we think is going to happen in the future based on the weather forecast. Obviously, this is less accurate because the weather forecast is inherently inaccurate. But what we're doing is being able to say, how did our machine learning algorithm predict real-time response based on forecasted data? So again, there's only so good we can get at the forecasted stuff, but as our machine learning algorithm improves, this will also improve. So to show you a sort of a real-world example where this was used to make decisions and confirm to Transport Scotland that everything was going well, back in September last year, there was a fairly large storm, Storm Ali, that occurred, and you can see from the data in Mercury that there was a large displacement at one of the bearings, so exactly where the problem was in 2015. There was a large shift there, which is just telling us that's what happened, that's fine. You also saw that at the truss end links there was, sorry, this was at the side towers actually, I think. Yeah, side towers. There was a big shift in the force that they saw. Again, interesting. The thing that was really important was the rocker, which was one of the bits that actually sheared before, is continuing to articulate normally, even though we saw those sort of extreme responses from the bridge. So you can say, based on this data, we know that even though there's been some extreme weather conditions, the bridge is absolutely fine, no issues, business as usual. So just pulling all this together, I've talked about Mercury mainly today around the innovative asset monitoring, but the Fourth Row Bridge team are also using lots of other sort of digital tools to create a truly smart bridge. So it's not just Mercury that's our cloud-based monitoring and analytics tool. We've also got a cloud-based system called Pearl, which is an inspection database. So that's what the inspectors use when they go out on the bridge. It's all cloud-based to do their inspection planning and recording. In the control room, they've used their 3D visualization tools. And in the bridge inspectors, they're starting to develop the virtual reality and augmented reality to really improve how they do their inspections as well. So this is starting to be pulled all together. That's the power of it, is combining all this to give you a really holistic view of what's going on with the asset and how you manage it. The interesting thing then for me is what's the next step in terms of just not just the bridge, but beyond the bridge, in terms of productivity of the whole network. How do you prioritize investment? Once you know the condition of your bridge and other bridges, for example, how do you prioritize investment across your whole portfolio of bridges in Scotland? So we should be able to take this from an asset level up to a system and portfolio level once we have that data. So yeah, in conclusion, it is about data, but as I said at the beginning, the data has to inform decisions. We are able to increase the resilience and confidence in the operation of the bridge using this, but it's also very important that, yes, the smart assets and data analytics really helps in terms of making decisions. It also allows the engineers to be more efficient in their time, so they save a lot of time, definitely with things like the automated reporting. However, the engineering judgment will always be necessary, so we're not replacing the need for the engineers. It will always be necessary, but they have more time to focus on the really important stuff to improve productivity.